2 minutes. Well, good afternoon, everyone. Welcome to this first afternoon session, session 6D, the triple play roller coaster. Before we start with the presentations, I would like to have 2 announcements. Please turn off your mobile phones. That would be very nice, convenient for all of us and also for the speaker. And please also fill in your evaluation form to get your present. And for us, from the program committee and from Tirena, to keep improving this conference. Therefore, we really need you to fill in those evaluation forms. As already said, this session is called the Triple Play Roller Coaster, and it's going to be like a roller coaster ride with free falls, loopings, 360 degrees turns. The first speaker we have today is Juan Manuel Munoz. He is from the IT management department of the Opera Oberta, the opera in Barcelona, where he is basically responsible for new developments, integration of software, and also co-directing of the department. So, Juan Manuel, the floor is yours.
Thank you very much. See? Good afternoon. Before I start, I want to say you 3 things. The first, my English is very, very bad. I'm sorry, I ask for excuse. And the second, the person who should be here with us today, Ms. Julia Osoria, Opera Oberta manager, could not have come for personal problems, and I have come in her place. The last, the title Opera Oberta, means open opera. I will refer always in this original title. My name is Juan Manuel Muñoz Martín. I work as IT manager in Gran Teatro del Liceu Opera House together with Julia. Along this presentation, we will talk about the following points: of the theatre, a small introduction of the theatre, of the own project Opera Oberta, and his evolution towards IPv6 and high definition, about safety solution or project on 6 version IP, our vision of expansion, and finally, a small introduction of demonstration from Barcelona if Murphy wants. Ever since the first plans in 1994 to begin reconstruction of the new Liceu Opera House at this historic location on Barcelona's La Rambla, everyone involved shared common aim to build an opera house for the 21st century, one that will meet the challenges that the new information and communication technology were beginning to set. The result of all this work has been a modern opera house connected to the main communication networks, in which audiovisual technologies play a leading role with a stage and auditorium that are probably the best equipped in the world when it comes to information technology. Today, 8 years after the inauguration of this new theatre, the Liceu is working towards fully developing towards its technological possibilities, with the belief that technology can be a way of fulfilling one of its main objectives: to search for the new ways and means to bring opera closer to the people, especially youngsters, and to create new audiences. A way, in short, finally, overcoming the physical and aesthetic limitations imposed by opera houses themselves. The desire to reach an increasingly wider people and maintain stable relationships with other cultural institutions has meant that the Liceu has launched a campaign to fill the historical vacuum existing between the centers promoting cultures and universities, that which historic deposit of that same very culture. These cultures promoters usually have programs aimed at children, teenagers and youngsters, but rarely there is any solid collaboration with the world of the universities. The Liceu solved this historical problem as an opportunity to unite art and technology and provide the public with an educational, imaginative proposal that will awaken interest within the university community. In this way, Digital Opera, the Liceu at University program, was born. The Digital Opera, the Liceu at University, comprised 3 projects aimed at university students. The first, and perhaps the most representative, is entitled Opera Oberta. It's a course aimed at universities throughout the world, based on a live internet broadcasting of a series of operas, accompanied by various classes beforehand, and complementary material on the web of the project itself. The second is entitled Opera Learning, or the Construction of an Opera. It's a course dedicated to studying all the relevant aspects of the construction of an opera via 6 seminars using high-quality video conferencing. The last of the 3 projects is entitled Opera Web and involves the holding of the competition for the design an internet portal based on a specific opera. This presentation will deal exclusively about Opera Oberta project. In May 2001, the Gran Teatre del Liceu decided to launch Opera Oberta project. The first experience was a high-definition format live broadcasting of the opera La Traviata on December 18, 2001 in Cinesa Diagonal, a digital cinema in Barcelona, while at the same time extremely high-quality signal are being broadcast across the Catalan academic network managed by CESCA to universities of Lleida, Girona, Polytechnic University of Barcelona, at its campuses in Barcelona and Terrassa, where the image was projected onto 5x3 meters screen, were specially set up for the event. The result of this experience encouraged the Liceu to consider expanding it, especially within the framework of what university environment entails. Therefore, a new definition of the project emerged, one whose was aimed to spreading the art of the opera amongst university students throughout the world. To achieve this objective, it was decided that the project will be based on a free choice university option that will logically have a course value for students and will comprise the following points. Within a series of operas, broadcast live from the Liceu, attending a conference for each opera, attending an introductory class for each opera, an internet portal with complementary content, and finally, sitting a final assessment exam. This new format was presented to various Spanish universities, and the aim in these first years was to test its viability with various renowned Spanish universities throughout the country, and also include a first experience with an international university. Forecasts were quickly exceeded, with many universities from the beginning expressing an interest in participating. The growing interest expressed by universities and the favorable reception by students to the project meant all the universities repeated the experience during all the academic years. The project results today have been highly satisfactory from both the academic and technological points of view. In addition, however, outcomes that were initially unexpected are being achieved, such as the existence of the virtual community which is becoming established around the course to be offered in identical form simultaneously in more of 50 universities in different countries. Evidence of this emerging community being formed on the basis of the Opera Versa project can be found in the number of registration made by students on the course portal, establishing electronic communication between them and the project, the huge attendance participating universities at the annual meeting held by Liceu in Barcelona, and ever-increasing group of technicians who maintain constant contact using the tools made available by the project. The transmission of the opera is distributed to the Spanish universities by Rediris. Rediris broadcasts to GEAN for European Academic Network, which distributes it in turn among the European universities in the project, and to Clara Latin American distribution by allies. Chile. The project was a pioneer in some of its technical features. It's necessary to distinguish between the different operational models in the project, and for all their needs to be covered. All the technical architecture is based on a European video distribution standard, DVB, Digital Video Broadcasting, which enables resource to be optimized, increasing the performance of the service. The anticipated encoding is MPEG-2, which enables information ratios of over 8 megabits per second to be obtained, supplying a better image quality than that of DVD. Using SDI, serial digital interface, at 270 megabits per second signal from the 7 robot cameras in the theater, the production team feed the DVB MPEG-2 encoder. Sala 501 means 501 room is a room of accomplishment and post-production of video or audio of the theater. As far as audio is concerned, for stereo mixture, MPEG-1 layer 2 at 384 kbps per second are transmitted during the previous seminar, for each one of the official languages in the project. In this case, Catalan, Spanish, French, and Portuguese. During the opera, 5.1 surround sound Dolby Digital at 640 kbps per second stream is transmitted. That can be reproduced at the university as an stereo audio or Dolby Digital 5.1 audio if the Dolby Digital encoder is available. Simultaneous subtitling that is introduced at source in various languages. Using the standard DVB, which enables the inclusion of a subtitle streams in a single MPEG-2 transport stream containing the audio and video MPEG-2 stream, synchronizing all the signals. The clients can thereby select the language in which they wish to see the subtitles. At the moment, 5 languages subtitles are sent. The 4 official languages in the project, again Catalan, Spain, French and Portuguese, and plus Galician. Maintenance of the rights adhered to the productions to be broadcast and compliance with the legal obligations make the encryptation of the transmitted signal essential. For this, VPMN, Virtual Private Multicast Network techniques are used, based on the creation of a virtual private network at each end, thereby allowing the destination university's firewalls to be crossed without any problem. Broadcasting is carried out by creating 2 multicast groups. The first contains an MPEG-2 transport stream, which include all the content, audio, video, subtitles, and control tables, and the second contains the keys necessary for decoding the content. For reproduction, the universities must have appropriate equipment for decryption, decoding, and language selection, as well as a projector large enough for the screen and room where they plan to use. Furthermore, each university needs appropriate sound equipment for reproducing sound in 5.1 or stereo format, as well as a sound and image technician to deal with the preparation of transmission and any eventuality arising during it. This is an example of the Polytechnic University of Madrid. Opera Oberta is a project in expansion and as such in permanent evolution. One important aspect to be considered is the necessary evolution of the project from the technical viewpoint. In this respect, projects along these lines, such as the application of the new IPv6, IGMP-v3 communication technologies, high-definition technologies, safety projects on IPv6 are already being promoted. And now arrives the moment of the publicity. This evolution and innovation has been possible thanks to Rediris, CESCA, Carlos III University of Madrid, CESGA, and Ministry of Industry, Tourism and Trade of Spain, of course. The opera is also broadcast on IPv6 network, and we are working in different projects to extend to use of IPv6 on the network. Another I+D objective in the Opera Oberta project has been high definition. Since 2005, the theatre has invested in equipment and has successfully broadcasted in high definition with a bit rate of up to 60 megabits per second. The anticipated encoding, again, is MPEG-2, but in high level. The source by high definition serial digital interface can deliver a 1.4 gigabits signal to high definition encoder. The characteristics of reception are as important as in emission for a real high definition experience in the end user. For this, once achieved the bandwidth required in reception, about 20 megabits per second, 2 points are essential. Have a graphic card with 256 megabytes dedicated video memory configured to projector native resolution, and of course a projector with 1080i native resolution, that is to say without interpolation. The improvement of the image obtained with regard to SD profile is really spectacular. As we have just seen, the Opera Oberta project also allows not only the culture diffusion, but the investigation and development of new technologies. Another example is the group of work that has been defined for the safety solution multicast of the digital content on 6 version IP. Nowadays, the specifications published on safety solution for environments of multicast in 6 version IP are very unripe. In fact, there aren't published specifications. Due to this, the researchers since in IPv6 protocol is going on to a specification definition, and the actual solutions look for general applications or configurations, but even implementation don't offer themselves for secure multicast flows. So this working group is going towards the specification to applicable secure multicast flow solution in IPv6. And again a bit more publicity. This project is being possible thanks to Gran Teatro del Liceo, of course, University of Malaga, University of Zaragoza, and Red Iris. Without them, it would not be possible. Design and implementation of this project searches scalability in number of clients supported, open source implementations based in existing protocols and standards, and finally obtains a light set-top box client. About our vision of expansion, the Liceu, Gran Teatro del Liceu, has international vocation, and the next year the Opera Oberta project will manage up to 8 different languages and will be in 16 countries. And now, if we have got time, we will see a bit more of the previous seminar and the small fragment of the opera Lucia della Mermul by Gaetano Donizetti. Let me introduce you to Xavi Carreras, our Opera Oberta technician, who will make the necessary adjustments in order to enjoy a bit of opera. And after that, we'll answer the possible questions that you should want to do, bearing in mind that his English is more or less so bad than mine. Xavi, when you want.
We must turn off the light to better image quality. In a reception center, like us now, the decoder recommended in the project is a VLC of Videolan. Now I'm going to connect to a multicast group, which is distributing now content from Liceu of Barcelona.
The background is the Opera Oberta web.
Jove que va salvar Lucia de l'atac d'un toro.
We must select in
Uns caçadors avisen que
4
Edgardo
languages.
Qu'Edgardo est dans les environs.
All are four audio stereos. This is a previous seminar of opera emission, opera
Scène
Oberta
2,
emission.
près d'une fontaine dans les bois de Ravenswood. Lucia attend Edgardo avec Alicia, sa dame de compagnie, et lui fait part des pressentiments tragiques qui la tourmentent. Près de cette fontaine eurent lieu de terribles événements. Jadis, une femme fut assassinée et Lucia est sûre de voir son fantôme. Edgardo apparaît et annonce à Lucia une triste nouvelle. Il doit partir en France. Auparavant, il souhaiterait demander sa main à Enrico. La jeune femme, connaissant les sentiments et les désirs de son frère, le convainc de rien lui dire. Lucia et Edgardo se marient alors devant Dieu et se promettent une fidélité éternelle. Ils chantent un magnifique duo d'amour et se séparent.
Okay. Now I'm connected to a group which content opera content. In this kind of stream, we can select in 5 languages subtitling. In this case, I select French. And audio, this content is in aspect ratio 430, but usually it goes in 69. It's the normal aspect ratio. And audio is usually in Dolby Digital, but in this case is stereo.
The subtitles don't appear because in Opera the repeated text is now subtitled. Yes. I have just seen a case of pixelation of video artifacts. As a little square around the screen is frequently and relatively habitual error. It takes place during the video transmission. It's important to highlight that what we see now in this moment is content recorded in our equipments, theater equipment, and being broadcasted live from the Liceu. But during the Opera Oberta sessions, the transmitted content is what is represented in that moment in the stage of the theater. Well, that's okay? Sí. Well, do you have any question for us? Thank you very much.
Okay, any questions? Sure.
You said on your high definition trials you're using MPEG-2 encoding. Have you considered MPEG-4?
Yes, but equipment that now have or we have was in MPEG-2, and MPEG-4 is a relatively new standard, and MPEG-2 in high level, it's, I think, and the test we have, it's correct. MPEG-4 it's another standard to try.
Just a second.
Hello.
Okay.
Good afternoon, Comrade Zakon from the Belgian government. So during your presentation, you discussed the fact that the stream may be secured and there might be also authentication to access that stream. So on the demo we saw right now, which was very impressive on the content itself, you just, in fact, subscribe yourself to multicast stream, of course. But how was working on behind that authentication mechanism in order to maybe limit the subscriber of that multicast stream? And next to that, was the encryption of the stream done right now? And if so, it was really fast because the video was so clear.
No, I don't understand. But I think that you are asking me about the emission goes now. It's encrypted or no encrypted. Now it's no encrypted because to do that we need a set-top box decryption module with a target with content claves, codes. But today we think it's better to do this because to assure the transmission and not complicate demonstration.
Any other question?
Hi. I must say that I've been to an Opera Oberta session in Polytechnic University of Madrid, and I must say that it's a great experience in audio and video quality. And I was just thinking about if you have any plans on delivering all these streams, not only to universities, but in another kind of project to homes. Also, of course, keeping the digital rights of the Liceo online.
No, well, it's all goes around author rights, and I think nowadays it's university and students circle.
And also not for the future. For example, if you would imagine that ISPs would consequently, implement multicast on their backbone, that this, for example, could be like a very disruptive approach where people at home could see with their video systems the opera?
I think it's a good line to go because culture arrives for more people and it's good thing. But this is from all kind of persons that ask. This is legal rights and another question.
Okay, we have the last question, sure.
Sorry, in the same direction of the question of the previous guy, but not going too far of delivering the content towards home, is there an opportunity, for instance, to deliver that content towards other operas locations? Like an example, in the Walloon region, in Namur, where there is all the big part of the government, there is a very well-known opera, which is the Opera of Namur, where that might be an opportunity to deliver that content to operas. So not to everybody on houses, but on operas location so that people can see operas and maybe live operas being on another city, on another country, but that one being, how can I say that, done, for instance, in Spain or other places. So having the content on other operas on other countries.
I don't understand.
But the question is, it's for like from when you have a video conference from classroom to classroom. Where on one side of a room you have the teacher actually teaching, and you're on the other room, other building, other place, you have the class just listening. Would that be a same or a similar scenario would be possible for your application, where you then would have in one opera actually the opera being played with the people and recorded and streamed to another opera building that has 5.1 equipment, and people just would sit there and it would be broadcasted with a beamer?
Reproduce opera in another theater.
Exactly.
It's possible to do this. I think if the occupation...
No, it's possible.
It's possible, no? Technology...
The only way we can make Opera Oberta is the academic world.
Yes.
By rights of our author and singers, big cash for.
Okay, then let's thank the speaker again.
Thank you for your patience and comprehension, and we hope to be no outlets in access the Shakespeare's language. Thank you.
Okay, our next speaker is Jean-Marc Uzet. Jean-Marc has a past within the academic field. He was working for Renater, the French research and education network, where he's been involved in leading in several international projects. Most of them were network projects. Since 2001, Mark is now working for Juniper Networks, and he's focusing still at the research and education network, as well as also the governmental sector. So Mark, the floor is yours.
Hello, everybody. Last year, if you attended my session, I started to talk about and introduce IP Sphere because I made a talk about end-to-end services. And so I introduced you IP Sphere for standardization and how it is relevant for end-to-end services. So my presentation today is the second act of my opera I started last year. And this year I'm going to talk about the technical specification, which are going to be released very soon. Actually, they passed the straw ballot a couple of weeks ago, and they will be voted first week of June. So then it will be released, published, and available to all. So I think everything starts, and you will see some blue templates, which are my slides, and I'm going to use also origin slide from IP Sphere Forum in green. Okay, I don't want to avoid any confusion, so that's why I use two templates. So the vision we have, and that we launched a while ago with the Infranet initiative, is we really see the internet evolving to a global network constituted of multiple domains that will coordinate their resource in order to enable end-to-end services with a certain level of quality of service, reliability, and security based on application requirements. So the application and the end user will be part of the network. I mean, the knowledge today it's really unaware of the end user. So we may have intra-provider communication or inter-provider communication, which is the most communication you have in your community. And in both cases, we need to coordinate network and computing resource in order to offer a service on demand to the end user. And in our vision, we believe that this IP Sphere Forum is going to bring this SOA level layer, which is going to coordinate this resource among different providers in order to trigger the service on demand. So the requirement of this layer is first it has to support both providers, so the virtual private, virtual network operators like the NRNs, but also it has to support computing resource in the picture. So we have to link both. And any policy, any business relationship should be handled by this layer, not necessarily a profitable commercial relationship as we will have with commercial operators, but also policy-based relationship as we have in the community, in the R&D community. And also any technology would be supported. It's not only IP, even if it's called IP Sphere, it's also Ethernet, it's also optical, so non-packet based network, and also the computing and software resource. So if we take a picture, for example, with a couple of NRNs, a pan-EMA backbone, and I include here also one site, for example, supercomputing center, we have basically three planes that are going to be used here. The data plane, where we may use GMPLS or IP or a pure optical layer, any type of data plane, including a router and logical router if we use virtual infrastructure. Then we have the control plane, where we have typically the routing protocols like BGP, but also maybe some GMPLS signaling protocol, etc. And on top of it, we have this service layer, this service plane that we call business layer in the IP Sphere Forum, or more technically SSS layer, which is service structuring stratum, where each provider will be able to publish their network or computing elements or secret elements in an abstract way, so that end-to-end service could be enabled when an end user requires it across multiple domains. So let's see this in more details now by looking at the technical specification. The service can be abstracted or contain an abstracted level which is all the set of attributes that describe the service and what it can offer to the end user. So this is how the service is proposed to the end user. And at the same time, it contains the set of attributes that describe how the service is actually constituted and how it's going to be enabled by listing all the required elements that will constitute this service. So then we have the elements, which contain the set of attributes that describe the visible properties of it, technically, commercially, and also it contains all the set of attributes in order to enable the resource in the network. So the element is very close to the real resource that is going to be used, like, for example, a routing service or end-to-end light path service, etc. And so a service is going to be composed by a set of elements that will be chosen on the fly, I mean, when a request comes from an end user. And we use this nesting approach so that the element itself could be constituted of a underlying a certain set of number of elements, so that we have this hierarchical approach in order to be extremely flexible in the type of service we can build. So the entity, the provider who is going to provide the service to the end user is called the administrative owner, because it will control all relationship with the end user. And each provider which provides one or more elements is called an element provider. And of course, an element provider could at the same time play an administrative owner, because he could provide the service himself. So the key is the template. And the template is going to describe the service. A template is going to describe the element. And this service structuring process is going to do both things. One is to publish and provide the service to the end user. And at the same time, we'll have the role of enabling all the set of resources that will be needed to fulfill the service that is requested. So what contains the template? It contains basically 4 types of information. Let's take one service like IPTV, for example, video on demand, this kind of service. It will contain descriptive information, which the name of the service, of course, but also the global ID. Each template will have a global and unique ID to identify the service in this global repository. It contains technical information, so the service level specification. For example, we need QoS for that service. We need a certain level of bandwidth. We may need also some codecs in the host to enable this service. Then it contains service level agreements, which contain all the commercial but also policy agreements between the different partners. For example, you may have in your community some rules to say only a certain set of projects are allowed to use this service across the infrastructure. Okay? And the last but not the least is all the policies that are used to select in an optimal way the different elements that are going to be used. To build a service from end to end, you may have different choices, like, for example, different paths. And you may have some policies here in the template to decide how to choose these elements in an optimal way. So let's take now the different functional elements in this framework. I'm a provider of a service. The first thing I have to do is to architect the service. So I'm going to take a template, either a standard template that is standardized in the IPsphere forum, or maybe a template that is just agreed between a certain set of providers. For example, the R&E community could be their own template to describe a service that only them use it, right? So we create the model, we fill the template with all the data, how we want to provide this service, with the description I gave you before. Then we publish this template in a global repository. So this is done by the publisher function. And then we wait for an order to come in. And this is out of scope of the IPsphere forum. The way you offer the service to the end user, maybe a web-based application, it's out of scope. We don't need a standard for that. Anybody could decide how you want to publish the service to the end user in order to have him trigger it, right? But when the user requests come in, then we have the function of the SMS admin that will take the template associated to that service, create an instance of that service because an order come in, and it will start to select the different elements in the global repository in order to fulfill and deliver this service. And there may be several choices, so it will take the optimum list of elements to build that service. And then it's going to be the role of the SMS parent to take this list of elements and contact them one by one to check if they can make the job. And in order to connect to all these element owners, so the different providers that contribute to that service, we use the SSS message bus for that, which is the service structuring stratum, which is this SOA-based layer in the IP sphere framework. In each element owner, we have an SMS child associated to that element that is requested. And this SMS child will check if really the resource is there, if I can enable it, and I will, of course, also monitor it, because if there is any problem at any time during the lifetime of the service, we use the alert client function in order to handle these alerts. So we have all these functions and some interfaces that are defined, and there are still some work to be done in order to describe all these interfaces precisely. But if we take just an example to illustrate that, we come back to our example with two NRNs, one PAN-EMEA network, one user requesting some computing resource or application in a computing center, supercomputing center. Then we have, in this case, a confederation of 4 different providers, the two NRNs, the PAN-EMEA backbone, and the supercomputing site. Some offer an access. The PAN-EMEA may be just a transit service. And the supercomputing actually offers the resource that is used by the user. Actually, any NRN could provide the service to the end user as the administrative owner. We don't necessarily have one unique entry point for a service. So NRN A could take the request from the end user, or maybe the PAN-EMEA network, or NRN B. It doesn't matter. It's up to, of course, you to decide. And also, all type of service are not defined in the IP sphere forum. It's up to you to create service, to create templates, and also to create the different policies that you want to use in order to select optimum elements. It's out of scope, right? You do what you want with this framework. And it's really driven by opportunities. So who will drive this process of creating new service, new templates? The user community, the NRNs, could be some industrial that could also provide you some added value here. And also politically, European Commission could also push for some development for new services. Let's see now what happens when an end user requests a service. The administrative owner takes the template, receive the order first. He takes the template associated to the service that is requested by the end user, create an instance of it, and go to the directory, global directory, to select all elements of service that can make the job. And then it will look at the element optimization data that are in the service template in order to select among all qualified elements which ones are the best. So we take the best based on the policies you have decided to use. And based on this optimization data, you take the best set of elements and you build a script. This is all the elements I need to build the service. And at the same time, the algorithm will calculate the different scripts corresponding to less optimal solution, because maybe the first one is not going to work because one resource is actually not really available. But then it will take the most optimal script, and will check with all element owners if the resource associated to each element is available. And really the way you decide which is a list of optimum elements, is really based on all the policies you have actually configured or added to the template. So it's just data you decide when you architect the service. What happens if one element owner says, no, I cannot offer this service? It was published in the repository, but when you requested it, it was not available anymore. If only one SMS child cannot offer the service, during the setup phase, it will send a not confirmed message back, and then the SMS parent will go back to the SMS administration and say, okay, the script you provided me cannot be executed. So I take the second one, because as mentioned you before, we will pre-calculate all the different scripts from the most optimal to the least optimal. So I take the new script and I start again by contacting the different elements. So this happens in 3 phases when you want to enable a service. When the SMS parent contacts each SMS child, it will use this in 3 phases. The first is the setup. I check if all elements have actually really the resource to provide this, service. If yes, then I execute them. And if all are executed, then I go to the assure phase, where each child, SMS child, will be responsible of monitoring the service it provides. So, of course, this SMS child is connected to the lower layer. For example, the management system that really connects to the different devices in the network. So, independently of the vendor that is used, of the technology that is used, this is completely agnostic at the IP sphere layer, right? If a problem happens at some time, so the SMS has the responsibility to detect the violation of the SLA and will send a message back to the alert client in the administrative owner. And of course, the administrative owner has to decide what to do then. I find another element, or I just declare a service not operational, etc. It's up to the administrative owner to decide. So there are some, as I told you at the beginning, what I described here is something that is in the release 1 spec going to be published in a few weeks. It has to be voted beginning of June. But there are ongoing work related to how can I integrate an external, an architectured external service. You may have other systems somewhere, and we want to have the IP sphere interoperate with all other existing, like IMS, for example, ITU, NGN, etc. Also, there are some details, harmonization to do with other standard bodies, and of course, details the interface, the data model further. So, I leave the roadmap for the slides so you can have a look to where they are and where they go. Interesting is in parallel of the specification, you have also some implementation work done, including a test bed where they will start to test the available software solution having implemented the IP sphere layer. I want to finish just with one concept that is really in the air in the research education community now, and we start to see some concrete projects related to that vision, the vision of generalization of virtualization. So the capacity of giving a slice of a physical infrastructure for a certain set of users, experimentation, etc. This concept is really feasible today because all the chain of elements today, if we look in the market, provide capabilities to virtualize a service. So a PC could be virtualized. We could have different virtual systems. Ethernet technology can be virtualized with VLAN. Routers can be virtualized with logical routers. The transport layer can be virtualized with lambdas. The firewall, very important. We don't talk much about the firewall, but the firewall is needed in the chain at some point. And it also can be virtualized today. And the server, of course. And if we want to build a virtualized infrastructure from end to end across multiple domains, then we need a layer to coordinate this. We need some software mechanism to do that. So this service plane or business plane could be used for that in order to, from a physical infrastructure shared by all users, dynamically enable a complete chain of virtual elements to offer this virtualized infrastructure for a specific experiment or project. Thank you for your attention.
Thank you, Jean-Marc. Any questions?
Hi, okay, working. Cameron Zacot from the Belgian government. So if I do summarize briefly the objective of the forum is, in a certain sense, to define services templates so that different ISPs or different NRNs can, on a common basis and common understanding, negotiate themselves a service all across the different boundaries. Okay. So my question is the following. In the Belgian government, we have a project right now which is named Vigie Telecom, where in fact the objective is to have a graphical association of maps and telecom services that are available on the country, and in order to enable administration, SMEs and even residentials to say, okay, I'm on that location or that set of location, what are the telecom services which are available for me? And within that project, telecom operators are involved. And we have defined, or we are currently in the process of defining, what's the same kind of stuff you said, template, services templates, so that all those telecom operators describe their own services towards that public service, which will be the portal of getting that information, but on a common basis, so that customers, being administration, SMEs and residentials, can compare those different services and select the one they want. So can the work of IPsphere and the work which was to have end-to-end services, can the work of that standard, in a certain sense, template, can be reused or also integrated in such kind of context, so that in the future, we might think that it's not only for telecom operators of Belgium, it can be from telecom operators from Belgium, France, because some SMEs have implementation in Belgium, but also in France. So that they will have, okay, I'm on that city and city in Belgium, but I'm also on that city and that city in France, Germany, and so on. And then, as they will have a common understanding of a service, like you did, it will be a larger scale.
Yeah.
So
absolutely. Absolutely. This is exactly the goal of the IPsphere. And to build a template, it's very important. You have two approaches. Either you need a really global agreement of this because it's going to address more or less everybody. In that case, it's important to get it standardized in the IPsphere forum, the template for a specific service. For example, currently they are doing that for layer 3 VPN service, which is a very famous one, or video on demand distribution, etc. Or the second option is this service concerns very limited community, for example, all the RNE community, and you do not necessarily need to get the forum to standardize the template. You could just agree between you to use the common template, but you use the standard framework in order to have all the chain of device compliance, including some industry solution you are using at some point at different layers, right?
Very, very brief point right now. In relation with this, there was a European project where Terena was involved 7 years ago, which was to negotiate quality of services inter-domain. It was the IST Tequila project.
Yes, which is so here. We use the same data model as in the Tequila project. Absolutely.
Thank you.
Really, the relationship with standardization body is not overlapped. There is no overlap. We use what exists in order to agree on common framework and template. But in the IPsphere forum, we don't create standard that overlap with others. So Tequila results are integrated, absolutely, as well as TMF.
Good. We have room for one more question. If not, then let's thank the speaker again.
Thank you.
This brings us to the last presentation of this session, and I would like to introduce to you Guy Clark. He will talk to you about a triple play survey within the university environment. Guy Clark has a background in telecommunications. He joined Global Crossing in 1999, where he today occupies the position of the European Director of Enterprise Product Management. Guy, the floor is yours.
Thank you very much. I'd also like to introduce Nick Rouget, an associate here from a company we're doing business with, who is actually Inuk, and they are providing the triple pay solution that we're going to talk about today. What I'm going to do is introduce to you Global Crossing as well, and the part we play in their triple play solution into the education environment. Many of you already know Global Crossing, I'm sure. Many of you take bandwidth from Global Crossing, either directly or indirectly via the other carriers. But Global Crossing today is very much more than a bandwidth provider. The last 7 or 8 years, through acquisitions and through organic growth, we've become very much a converged IP services provider, be that managed or unmanaged. And about half our revenues today are not from the carrier space, but are actually from multinational corporates. So we're going to talk to you today about, say, very much this triple play solution. Triple play being TV, VoIP, and broadband connection for students. Nick will dive into that in some detail. We'll also talk about the commercial opportunities for you. But where do Global Crossing fit in? As I mentioned, we very much sort of evolved over the last 7 years. And if you look at us today, wholly owned IP network, what a lot of the incumbents would call a next generation network. So it's MPLS over DWDM, over our own fiber, and we reach somewhere around 600 cities in 60 countries and 6 continents. So quite a vast network now. In terms of VoIP, and this is really the key part we play in the triple play solution here. In terms of VoIP, last year we carried over 30 billion VoIP minutes over our network, very reliably indeed, consistently hitting the 5 nines service availability that you would expect in today's environment. A lot of that traffic doesn't originate to us as IP. It actually comes in as TDM, and we convert it to IP on our backbone. So in terms of customer minutes, we've got about 400 or 500 million minutes a month that are IP. Our network, in terms of routing VoIP traffic, consists of a number of Acme session border controllers that control the security and the control of the sessions of any of the VoIP traffic on our network. And we have a huge number of Sonos soft switches as well as Sonos media gateways. As I mentioned before, a lot of the traffic comes into us still as TDM. Even in this lovely next generation network environment, many of the networks still are not there, so we do a lot of conversion. So where do we fit in terms of the Inuk triple play solution? Well, clearly little Hannah and little Hans at university, much as they don't necessarily want to be communicated to by their parents, have to have some kind of link to the outside world. And that's where our VoIP network and connectivity via the media gateways to the PSTN enable us to provide DDIs and non-geographic numbers so that little Hans and little Hannah at university can be contacted by mum and dad to say, are you still alive? And similarly, again, much as youngsters don't like to communicate to the mum and dad, occasionally they do need to phone up and ask for more money. So similarly, the connectivity out to the PSTN enables students to reach out to the mum and dad via this solution and via our network. Just a very dense slide here, not for talking about particularly here, but this is an overview of Global Crossing's current capabilities. Very much a converged network, as I say, over IP, and I'll leave you to mull that one over at your leisure and any handouts you've got and the presentation you can download. But I will swiftly now hand over to Nick Rouget of Inuk, who will talk through the triple play solution.
Thanks, Guy. So Inuk is a UK-based company that is specialising in delivering triple play services to students. particularly to start with students in halls of residence. And so I'll explain a little bit how we do that and some of the things that we're doing in the UK and how that's growing out into other networks around the UK. So just a little bit of background about TV and voice for students in the UK. This grainy photo taken here, you can probably see it better on the smaller image, is basically typical of many universities if you walk around them in the UK. Because these buildings are concrete floors, concrete ceilings, reception for TV using an aerial is very, very bad. So students often have to hang their aerials out of the window to try and get some sort of foggy picture on their TVs. So TV reception's always been a problem. We're also going through this process in the UK, as I know many of you are across Europe now, starting the switch over from analog signals to digital signals. And if you tried to pick up digital signals using a small portable aerial on top of a TV, if you can't get a very good analog signal, well then when you get a digital signal you're not going to pick up anything at all. So students are receiving poor TV, no multi-channel TV offerings. The universities in the UK certainly won't let students put satellite dishes outside their buildings, run cable networks in, etc. So students haven't got very good TV service, and it's going to get worse. And of course, as everyone knows, TV is an essential part of any education for obviously the lots of research content that's on TV. So the universities have got a problem with TV. If we also look at telephony, universities in the UK for a while now have had telephone handsets in the bedrooms for students, running analog systems, normally calling cards, and often the companies that put these systems in, because they're trying to recoup the cost on a lease of a PBX, an expensive analog PBX, are uplifting call rates and trying to overcharge effectively students for these call minutes to pay for the system. Now, of course, students these days, especially since pay-as-you-go mobile phones have become commonplace, all students in the UK now have mobile phones. And the students, of course, are all now using Skype and Dialpad and Teleo and Google Talk, etc. So using VoIP. Now, the universities are going through this dilemma of, do we block VoIP? Do we allow VoIP? Do we try and push students to use one particular VoIP provider? Issues over security breaches now through SIP. I know that UKERNA, Janet, done a paper that's on their website at the moment, where they took a PC with nothing else on it, a clean PC, loaded Skype on it and let it to run with Skype. And when they came back after a week's time and looked through it, how many viruses, Trojans, all these sorts of things were on there. So questions over what do we do with VoIP, but also how do we make these telephone systems that we've put in and that are obviously expensive and now not getting used, how do we give the students something valuable so that they can actually communicate back home? So that's kind of the background. So INNOC Networks launched last September a platform that we call for the student market FreeWire. Basically a data service, a telephony service and a VoIP service specifically for students. So if we go into look at each of the particular elements in detail, so TV particularly, there's a lot of stuff, I'm sure you're reading the same blogs and news stories that I do about Juice and Venice Project and Skinkers and Take It Off the Internet, all of these peer-to-peer applications that are coming and heralding that they're going to change the way people consume video. The problem with these peer-to-peer applications, of course, is that while some of the guys behind Juiced and Venice Project, and this is why they're getting a lot of publicity, have created file download organisations like Kazaa and then gone on to do Skype with voice, when you use peer-to-peer to do small file sharing or to do voice, you're actually using up very small amounts of bandwidth. But once you start getting into video, then we start getting into crazy bandwidth. So you can see on here 1 hour of near broadcast quality viewing, typically 320 meg. Now, the problems that universities are finding with peer-to-peer is not necessarily that students watching peer-to-peer are consuming lots of bandwidth, but because students are on fast network connections in the UK on Janet, their upstream bandwidth is being hijacked by these peer-to-peer applications. And so particularly we see it in university networks in the UK when there are things like Champions League football on. The download speeds through their Janet connection actually do go up a little bit, but what happens is the upstream basically goes flat out because all of the spare capacity bandwidth in the university is being used up by everybody else who's trying to watch peer-to-peer everywhere around the world. So the universities are starting to say, students are relying on this for TV, but we need to start blocking these applications, and we've got universities who are coming to us all the time saying, 4 ODs now launched and it's causing us problems, different services one by one. The question is, do we actually block these? Now, the reason peer-to-peer for video is taking off is a fairly obvious one, and hopefully I don't need to preach to anybody here about the benefits of multicast. The multicast is kind of the holy grail for delivering video over networks. If you want to deliver high quality video and you want to do it in an efficient way on a network, then this is the way you do it. The problem is that the majority of, certainly in the UK, residential networks, so certainly BT's network is not multicast enabled until the latter end of 21CN, which is quickly turning into 22CN. And broadband providers are starting to unbundle exchanges and are rolling out multicast, but multicast isn't everywhere. But so in a residential environment, peer-to-peer is possibly the only way for video at the moment. But within the education space, where we have multicast enabled on most of the RENs and university networks, multicast provides a real safe route for universities that want to deploy video. So we partnered with Ukerna, with the Janet network, nearly 2 years ago now. Our company, Inuk, started as a spin-out of the BBC R&D, who'd been pioneering multicast about 7-8 years ago, and had started a technical collaboration with Ukerna back then. We went to Ukerna about 18 months, 2 years ago, and said, we're looking to take this technology approach and take it into universities. We're talking to universities. They want to be able to offer TV in this way, but they have a number of problems, and I'll go into some of those problems and how we've tried to address some of those in a second. But so basically, the way it works is this is obviously a very simplistic cartoon diagram of how it basically works. But so if you look up at the top of the screen up here, what we're doing is we're basically taking video feeds, either direct over SDI fiber, terrestrial satellite feeds. We're taking in those feeds, we're encoding them into H.264 MPEG-4 so that we're getting the best quality but using the smallest amount of bandwidth. Then we're basically then taking an encryption server here using widevine encryption, putting a middleware wrap around this so that we've got billing information, digital asset management, EPG data, so programming information, etc. We can also take VOD content and ingested, perhaps universities' own archived lectures, health and safety videos, etc., put those into linear streams, and then, can't quite see where the mouse is, and then basically peering onto the Janet network, which of course is multicast enabled, meaning that organisations that are connected to it that open up to receive those multicast group addresses can receive the service. Now, the couple of issues that when we talk to universities, when we went in and first started talking about here is a solution, the two things that were really a problem for them. The first was, when you build an IPTV platform, what you generally do is you start with a set-top box. So we started with a set-top box, and if you want to do things like widevine encryption and those types of things, that's the way it's traditionally done. But when we talked to universities, they said, well, guess what? Students don't generally have TVs. They're in very small rooms. We don't want them to bring TVs because of power consumption, but all students have laptops. So can you provide this type of service on a laptop? So what we've developed is what we call a virtual set-top box. So this is a software application that emulates the functions of a set-top box and does the same API calls into the middleware, the encryption, all of those types of things. So we have, if we plug our set-top box in on a full-screen TV, the interface looks exactly the same when you run it on a PC. So this is full-screen, broadcast quality on a PC and on a Mac, obviously, as you can see here. So basically, when students open this up, they've got a full EPG so that they can go through and see what's on now and next. They can pull that into the sort of grid type thing you see on a digital or cable box with picture-in-picture and manipulate around that EPG, set in reminders, those sorts of things. And then, of course, they can go back and they can sit and watch TV. The second piece of this was the concern around the licensing of channels. So what we've done with FreeWire is we've gone to the UK broadcasters and almost acting, I guess, on behalf of all the universities, done licensing deals with each of the key broadcasters in the UK. So what we can do is we can deliver the technology platform into the universities deliver the client software so that students can use TV without having to buy any expensive boxes. But what we also do is make sure the university hasn't got the broadcasters knocking on their doors saying, hold on a minute, how come you're broadcasting our channels, etc. So we go and sign license deals with these channels and many more. So that's the way the TV piece of it works. The voice piece uses a similar approach. If you think about what we've done with the TV piece, we've taken all of the encoders, all of the central systems, and we've built one big broadcast or telco type head end that then the universities can access using the Janet network. We've taken a similar sort of approach with voice, where what we've done is tried to build a voice platform that works on closed IP networks. So if you think about the voice applications that students use, they're very used to using the likes of Skype and the types of software applications where literally you download a client, you register yourself, and then you're up and running and you've got free calls. The problems you have is it's peer-to-peer, the quality sometimes isn't very good, it's very difficult to add new applications on there and to start being sophisticated with your call process. So what we've done is we've basically built a voice head end with SIP session border controllers, SIP application servers, presence, billing, etc. We've built a prepaid architecture, which is obviously important for students, so that they can top up an account on the web and then actually use that credit or get the parents to top up that account. But then students can access the service by downloading a simple VoIP client. We also provide a SIP handset solution. So some universities want to put handsets in the rooms as a welfare piece so that when a student comes in, they can receive calls from their parents, they can call room to room, call their professor, their lecturer. So we do have a SIP handset solution, and we can also connect the university's existing PBX so that the FreeWire network can connect and make free calls between the university network as well. So if you're running that on a closed network, and so if you think about university in Edinburgh runs this platform and has handsets in their rooms, every call made across the Edinburgh network is on net, and so we can effectively guarantee some sort of class of service. If universities elsewhere around the country are also connected to the Janet network, although this piece isn't a Janet endorsed service, you're effectively still all on net, so you're not touching the public internet, which makes calls, of course, free, but also hopefully better quality. The next piece of this is we can break out onto the internet. So mum and dad can download the software as well. They can buy a SIP handset if they want. And so they can then stay in touch with their kids back at college, and it doesn't cost them anything to do this. And so some of the universities we're working with now are actually giving, when the students arrive on the first day in their first year and come into halls, and they have a starter pack with a telephone, the university are giving an earpiece and a CD in a nice pack and saying, here's a FreeWire telephone pack to the parents that the parents take home so that they don't have to pay for calls to stay in touch with their kids. So still free, but using the public internet. And then the last piece, of course, is which Guy alluded to, is where we then break out onto the PSTN. And so we're doing PSTN breakout for where students want to go out and pay for a call, and we're doing rates because this is aimed at the student market, and it's a kind of, if you can't beat them, join them. We're doing rates at around 20% less than Skype. We've got to deal with the National Union of Students, where if a student's got a student card and they register that student card, they get further 10% discount. So trying to make the calls as cheap as possible for the students. So handset and soft phone. So these are some of the universities that have started using the service. University of Leeds, who I know are here, were the first in the UK. So these are some of the customers, some of the trials. By September this year, we have 140,000 rooms in the UK that will be using TV, voice, or both. Lots of other interesting spin-offs from this. So one of the things that we're trying to pioneer here is offering tailored advertising to the broadcast channels specifically for the student segment. So at the moment, when Channel 4 pumps out adverts, those adverts are the same to everybody in the UK. So what we can enable them to do with multicast and doing multicast insertion at the edge of the network where it's obviously the bandwidth is cheaper, we can insert ads specifically targeted at the student demographic. We also have return path real-time reporting. So wherever I am with an internet connection, I can log in and I can see who's watching TV. I can watch what happens when adverts come on. I can see which bits in the news students are most interested in, and we can start cutting that data with different demographic data we've got on our users, and start providing broadcasters with real-time information about how people watch TV. And we're also doing some things with some companies, initially some research organisations that use students to conduct research. Normally those students have to go in part-time, sit in an office and make calls. Well, we can do this using the FreeWire soft phone. They have an account, they open up, they get popped calls through from a central call centre, and the students are online with a script on their PC, and they're able to do research work without even leaving their bedroom. So last two slides, very quickly, where next? We're taking this beyond campuses. I've got 5 minutes to slow down. We're taking this beyond campuses. So as I said to start with, Janet is multicast enabled, and so for the TV element of this piece, TV is relatively straightforward to run across the Janet network and then universities. When students leave after the first year, typically in UK universities you'll get a place in the first year. For your second, third, fourth year, you're out renting a house off a private landlord. So using some of the local loop unbundled ISPs in the UK, we're launching this September the same triple play service, but over local unbundled DSL. So the student can take the same FreeWire service, exactly the same look and feel. They can now have a set-top box if they want a TV in their lounge. Their credit account carries on, and so they can experience FreeWire in private accommodation as well. And the last piece of this is we're now starting to look and go beyond the UK. So this model of taking a centralised server, the multicast streaming, the virtual set-top box that we've developed, and then going into a country and doing content deals with the broadcasters is something we're starting to do in other markets. So the most advanced of those is Canary in Canada, and we're running a trial at the moment with Waterloo University, and doing carriage deals with the broadcasters in Canada. We've got the UK streams of these channels are now being piloted on HeNet, and we've got 2 universities in Dublin that are accessing the streams there, and we're looking to do that next. Australia, and we're also working through a partner organisation with an organisation that's working with SUNET to provide something similar as well. So the approach can work in other countries as well, and so we're very keen to talk to any RENs that are interested in this sort of partnership approach to deliver TV into students, into halls of residence. Okay, thank you.
Nick, Guy, thank you. Any questions? Again, me, sorry, government. One of the nowadays trends in digital TV is like, for instance, on Juiced or on Microsoft for Xbox Live, or even on Alcatel on Amigo TV, is to let the audience not be an audience staying on a chair and watching to the channel, but also have the opportunity to share the experience with the other audience, like exchanging instant messages, like having a voice call, but in between of watching a movie, or sharing a small part of a movie. Okay, I just saw the shoot of the football game, and I just send this extract towards the other friend.
Yep.
So are you thinking to those kind of things today?
Yes, we are. And the way I've presented this is very much TV and then voice as separate things. But where this gets interesting is where these start to converge. So we've already building widgets that go into the TV application. And so we've got call ID and messaging and those sorts of things on screen. We're doing things like a presence bar. So you know how you have your MSN bar and it shows you who's online? Well, it will show you who your friends are, and it will also show you what channel they're watching. So if you come in and you've missed a bit of the first minute of Sopranos, you can see your buddies watching it. You can say on the PC, hey, what are you're watching, what did I miss? Those sorts of applications. And user-generated content is the next piece of this as well, where students can start to create their own channels effectively, can email or text in video clips. Those can then be presented on a web page. They can pull them into a linear stream, and then they can be made available to their friends so they can watch those online. So it's kind of like a bandwidth-efficient way of doing YouTube, I guess.
There's one more.
You had a SIP-based voice over IP service.
Yep.
There's a task force in Treno that where some countries are preparing a open SIP-based SIP service. Will we be able to dial in to HANA at Leicester?
Yes. Yeah.
And HANA can dial back?
Yeah, we need to, so peering between different VoIP providers is easy technically, but it's the agreement of those VoIP providers. So we want to do that sort of thing. It's difficult for us to peer with other, you know, if we wanted to peer with Vonage, then there are commercial implications of that. But if there are other SIP infrastructures that we want to peer with, that's absolutely possible, yeah.
So what kind of agreement do we need to have to interpret?
We can talk about it offline.
Okay.
It's easy to do.
If I can add to that, certainly as global crossing, we do peer with other providers already, and effectively then calls between the networks are free, with the only charges being for the physical connection and simultaneous session capacity on the session border controllers. So we're looking to expand our community of people around the world that wish to connect for free, as it were, call for free, certainly in terms of the usage base being free.
Okay, one more question.
Brian O'Hara at Trinity College. What type of controls can you delegate to the university?
In terms of what?
Well, in terms of accounting and, you know, who's seeing what, when.
Yep.
Like, I can see small problems, like, you know, members of staff looking at TV and, you know, we'll be, you know, the IT department will get caught in between, and it'd be nice to have some accounting, you know, management information available.
The way, so we give every university, and I can show you this afterwards on a wireless connection if you want. We give each university their own login where they can go in and they can manage basically their setup. So they can see who's watching and all those types of things. But the way we set it up is, the way we can do it is we can give different packages, so different types of channels or viewing during, even down to different hours, based on IP address. So if I go into the system and I look at University of Leeds, I've got University of Leeds Language Centre set up, different IP range, and I've got which channels they've got. I've then got each of their different halls. Some of their halls are on gigabit feeds, some are on 100 meg feeds. They can have different channel packages because of the amount of the bandwidth. The other way you can do it as a university is by limiting the multicast addresses on a switch-by-switch basis. So if you enable multicast in through your firewall, that's the first piece of it. The other piece is then enabling multicast on each of the different switches around the university. So if you don't want lecturers sitting watching football all day, basically you don't multicast enable their switches.
Does that answer your question?
Answer, yeah.
Good. Well, Nick, Guy, thanks once more. This brings us to the end of the session. Thanks a lot for attending. Enjoy your coffee break.